Hello everyone, my name is Charles, and today I'll be going over the basic functions of my DEX Aggregator project, built using the Solidity programming language, and created as a final project for the DApp University online mentorship program. Today I'll be demonstrating the basic functionality of this DEX Aggregator project using a pre-selected set of mock tokens to simulate the functions of an actual application that might be deployed to a public blockchain. So first, what is a DEX aggregator and how does it work? DEX aggregators are decentralized applications that work collaboratively with decentralized exchanges, also known as DEXs, to calculate the best available exchange rate using live trading values from the blockchain. They use special algorithms from participating exchanges to route the best trading options available at any given time. So let's say we're planning on exchanging cryptocurrency on a public exchange, and we want to make sure that we get the best possible deal at that point in time. What do? Presenting Turbo Shell Aggregator. This decentralized application on the blockchain will automatically compare available prices between participating exchanges and then route us to the best available deal as pictured here. For purposes of our simulation, we have implemented two fictitious cryptocurrency exchanges known as DAppSwap and AppleSwap, along with the publicly available exchanges Uniswap and SushiSwap. The tokens used for the fictitious exchanges can be seen here, which includes the DApp and Apple tokens, as well as a third USD token, which is shared between them, giving us a total of 3 token trading pairs. In addition to these, we will also be featuring a testnet simulation of the publicly available token pairs, which include both wrapped Ether as well as the DAI stablecoin, each of which are forked onto the project via their original mainnet addresses. Here we have the active website for our front-facing DEX aggregator, along with each of the two participating exchanges, created for the purpose of simulating the same kind of functionality that we might see on a live exchange. As you can see here, each of these websites is complete with up-to-date values for all of the participating trading pools, shown here in the blue drop-down cards. Shown here on the tabs, we can see that DApp and AppleSwap are both complete with swapping capabilities, which automatically calculate the exchange rate in response to the desired input value. Note also that the form will continuously recalculate the exchange rate with each successive keystroke, and this change in value has to do with the percent ratio of total volume locked into the liquidity pool at any given time. In addition to swapping, the deposit and withdrawal functions are also available on the decentralized exchanges, which allows us to adjust the size of the liquidity pool according to our preferences. And finally, updated graphing data is available, which accurately tracks all the swaps on the exchange since the time when the contract was first deployed and compares the exchange rates for each individual trade as shown in the list here. So now let's go ahead and watch what happens when we try to submit a trade as it actively routes between the participating exchanges, which are shown down in the list below here. You will see that the drop-down menu allows us to select from any one of these 5 available tokens. The first 3 tokens shown on the list relate to the fictitious exchanges mentioned previously, and the remaining 2 tokens, DAI and wrapped Ether, relate to the public exchanges Uniswap and SushiSwap. Because these 2 tokens are in a separate category, you will notice that by selecting any one of the tokens from the first category, that the drop-down menu then locks it into that same category for the output token. Similarly, when either DAI or wrapped Ether are selected, the corresponding output token will be locked into that category in the same way. So keep in mind that because these tokens are in two separate categories, they are not cross-compatible and cannot be exchanged directly as a result. Before we get into trading with our aggregator, I'd like to point out briefly that I went ahead and locked in the exchange rate values to specific values for testing purposes. You can see here that the exchange rates corresponding to DApp swap are set at the values of 1.2, 1.4, and 1.6 respectively, whereas for Apple swap, all exchange rates are normalized to set values of 1.0 for each of the three liquidity pools. So let's go ahead and watch what happens when we try to perform a swap on TurboShell using mock tokens coming from either one of these two fictitious exchanges. If we select DApp and USD tokens, you will notice that it is now routing to the DApp swap exchange, meaning that it has now selected the best option between the two participating exchanges for the current available exchange rate. If we go ahead and type in 1, it is now giving us an output value of 1.2, which corresponds to the liquidity pool on the DApp exchange seen here. Now, if we invert the orientation of this trade going in the opposite direction, you will notice that the DEX aggregator is now routing to Apple swap with an exchange rate of approximately 1.0. Now let's go ahead and test for the two remaining token trading pairs to make sure that it is working for all three possible orientations. We'll go ahead and do a swap with Apple and USD tokens, routing to DApp swap with an output of 1.4. When we invert the trading pair, it gives us Apple swap with an exchange rate of 1.0. Finally, we'll go ahead and attempt a swap with our third token trading pair, DApp and Apple. As you can see, it's now routing DApp swap with an exchange rate of 1.6, corresponding to this liquidity pool seen here. We'll go ahead and invert the trade one last time, and it is giving us Apple swap with an exchange rate of approximately 1.0. And one last thing to note, the graphing feature is also available on this DEX aggregator project. It will automatically route the trading information obtained from the active exchange, being routed at any given time, as seen here for comparison. And similarly for Apple swap. All right, so that covers the functions of the exchange aggregator with respect to the two fictitious exchanges created for the purposes of this project, DApp swap and Apple swap. Now let's go ahead and see if we can also use this aggregator project to route a successful trade between two publicly available cryptocurrencies on the mainnet with the help of special interface command contained in the aggregator smart contract. Uniswap and SushiSwap are two publicly available cryptocurrency exchanges that are both decentralized and offer a wide variety of tokens available for trading at any given time. The tokens we will be using today are going to be the DAI stablecoin with the symbol DAI, as well as the Wrap Ether token shown here. For reference, we can see that the exchanges loaded onto the aggregator are simulated from actual values taken directly from the liquidity pool addresses, which are publicly available as shown here. So let's go ahead and try one of the last set of trades, except this time it will be with our second category of tokens featured towards the bottom of the drop-down menu shown here. If we try selecting DAI as our input token and Wrapped Ether as our output token, we can see here that the aggregator flags SushiSwap as the active exchange being routed. When we invert the trading pair with Wrapped Ether as the input token, it will then invert to Uniswap as the active exchange. The DEX Aggregator project is also fully capable of actively performing swaps on these simulated exchanges with the help of specialized interface commands built into the Aggregator smart contract. For demonstration purposes, I will go ahead and submit a swap which will be simulating the exact functionality of how each of these two exchanges actually function on the Ethereum mainnet. So let's go ahead and perform a quick swap with one of these two public tokens. We'll go ahead and use the DAI stablecoin as the input token and wrapped Ether as the output token. In the balances for the liquidity pool, you will see that we are working with a nice even number of approximately 4.3 million DAI. We'll go ahead and put an input value of 25,000. It gives us an output of approximately 11 wrapped Ether. And the trade is a success. We'll go ahead and refresh the page. Now we can see that the liquidity pool balance for DAI and wrapped Ether on SushiSwap has updated to a value of 4.3 million plus 25,000. So the trade was successful. And then finally, we will do one last swap using wrapped Ether as the input token, DAI stablecoin as the output token. And as you can see, it is now routing to the Uniswap exchange. Just like we saw before, we'll be working with a nice even figure for the trade of this liquidity pool, preset to a value of 3,000 wrapped Ether. Let's go ahead and input a trade for 123 Ether, giving us approximately 230,400 DAI tokens in exchange. The swap was successful. Let's go ahead and refresh the page. And now we will notice that the final balance is set to 3,000 plus 123 wrapped Ether. So this confirms that the trade did in fact go through, and the balances for the liquidity pools were both updated as a result. So this concludes the presentation portion of the TurboShell DEX Aggregator project built using the Solidity programming language and which fulfills the course requirements for the DApp University online mentorship program. In part 2 of this video, I will take a few more moments to cover some of the code structure that went into the design of this project for anyone who might be interested to see a little bit more of what is going on under the hood. My name is Charles, and thank you for taking the time to watch my presentation today.